Amazing people, got another example to work through now. So a number of $1,500 is invested at the end of each year in a superannuation fund. Interest is paid at 6% per annum. How much money will be available at the end of 25 years? So with this here, what we want to do to start off with, we need to work out each year one at a time. So let's work out year one, what the value is going to be, year two, year three. Then after we've done year five, we're going to jump ahead until we get to the final year here, which is 25. Now, one key thing with dealing with this is we have to pay attention to what the question is asking. And the thing here is, for this question, it is at the end of each year. That's really important to remember here because it's going to affect the formulas we're about to use with the compound interest. So here, what that's going to be, for the first year, that's going to be 1,500, bracket 1 plus 0.06 being our interest rate. Now, the power of n here, in that first year, because it's only contributed at the end, that's actually going to be equal to 25 minus 1, okay? Because it's not earning interest in that first year. It's only earning interest for 24 years after that. So therefore, we can factorize this a little bit, or simplify it rather. We get 1.06 to the power of 24. Now, as we keep going on, we're going to have the second year here, and this is going to be 1,500. Again, 1 plus 0.06 to the power of 24 minus 1, which, as we simplify, gives us 1,500 times 1.06, and that's going to be to the power of 23. So as we get to year three now, the amount we're going to have is 1,500 times 1 plus 0.06 to the value of 23 minus 1. And that's going to be equal to 1,500 times 1.06 to the power of 22. And lastly, year 25, so this is the 25th year, what we have is 1,500. That's going to be to the power of 1 plus 0.06. This one is going to be to the power of 1 minus 1, because it's not earning any interest at all. It's just being contributed at the end. So we have 1,500 times 1.06, and that's going to be to the power of 0. So that's the first 3 years, and the final one worked out for it as we established a pattern now. So now what we want to do is we want to work out what the future value of this is going to be. So for this case, we're going to have the future value is equal to A1 plus A2 plus A3 plus ... all the way up to A25. So let's establish this here. So we've got 1,500 times 1.06 to the power of 24 being A1. Then we're going to have 1,500 times 1.06 to the power of 23. Then we're going to have 1,500 times 1.06 to the power of 22. And then to the last one, which is 1,500 times 1.06 to the power of 0. So this is what our geometric series is going to look like in this case. Now, what I'm going to do in the first instance, I'm going to factorize that 1,500 out. I'm going to have 1.06 to the power of 24 plus 1.06 to the power of 23 plus 1.06 to the power of 22 plus ... 1.06 to the power of 0. So this is the pattern we've established now, and we're starting to get it. And you can start to see that we have a geometric series here inside the brackets. But we need to rearrange it and reorder it in order to be able to deal with it. So we're just going to kind of swap the order around. So what we're going to do is we're going to start with 1.06 to the power of 0 plus 1.06 to the power of 1 plus 1.06 to the power of 2 plus all the way up to our last amount of 1.06 to the power of 24. Okay, this is all the values we've got here. Now, as we work this out, our sum then to 25 of these amounts here, well, this is going to be equal to 1, because that's the first value that we have in this here. Then it's going to be bracket 1.06. Okay, now the power here is actually going to be 25, because there are 25 in here. It's just the first one is to the power of 0, so it works out to be 1. Then we're going to minus 1. That's all going to be over 1.06 minus 1, those brackets. Now, the last part of this is we want to roughly work this out. So this is going to be 54.86. This is rounded to 2 decimal places. Now, in order to be able to finalize it, is we need to multiply that by 1,500, because everything we've done for this sum here has only been the brackets. We haven't included the other part, which is the 1,500. So the future value of this is going to be equal to 1,500 times 54.86 And this is just like when we're reading off a future value table. And so this gives us an amount of 82,296.77.